In some ways, arrays are fairly typical and similar to arrays in other languages. Each value is called an array element, each of which has an ordered location in the array with a numeric index to specify its position. Arrays in JavaScript are untyped, so that each value in the array can be of a different type or all of the same type, mixed and matched, even consisting of other objects or arrays. This ability to hold a variety of often complex types in each value opens up some possibilities of creating complex and flexible data structures. JavaScript array indexes are 32-bit non-negative integers that are zero-based. So you can have an array with up to some 4 gigabytes of values. Arrays are dynamic and can grow or shrink as you need without any requirement of declaring the size when you create the array. Arrays can be sparse, so you don't have to use all of the indexes, nor must all indexes be contiguous. However, array indexes are in numeric order. As you'll see, the array indexes are really just object property names that happen to be integers instead of strings. All arrays inherit properties from the array.prototype object, giving arrays a rich set of methods that you can use to manipulate arrays and their elements and values. There are 2 basic ways to create an array: using an array literal and with the array constructor. An array literal is simply a pair of square brackets that contain a comma-delimited ordered list of items to initialize the array with. Each array element must be a JavaScript expression, but most of the time you'll probably use simple literal data types, such as integers or strings. Here's some code that shows a few examples of creating basic arrays using array literals. This first statement will create an empty array literal array with 0 elements. This second statement creates an array consisting of 7 integers. This third example creates a mixed array with a variety of data types, including Boolean values, integers, an object with initialized x and y properties, a string, a date type set to the current date and time, and the value at index f in int array added to 1000. So the message of this example here is that you can use a variety of data types as well as expressions. So this is an object literal, there's a string, there's a constructor method that returns a date object, as well as an expression that reads a value from this array and adds 1000 to it. This last value shows how you're not limited to simple data types and can use expressions to set an array's value. And then this sparse array example creates an array with non-consecutive array elements. And then finally, weird array is an array with 5 elements all set to undefined. I've set a breakpoint down here at the ending script element. So I'll come back up here to the code, go to the browser, and reload the page so that we can examine these new arrays. So the first one is the empty array literal. As you can see, it has a length of 0, it has no elements, and the prototype is the array object. All right, here's the contents of int array. As you can see, the 0 array element is set to 1, the number 1 is set to 2, 2, 3, and so forth, matching the set of values that you included within the array literal. These are some additional elements that are added by later code. And as you can see, the length property has a value 1 greater than the highest index value. And I'll talk more about that shortly. Here's the mixed array. So there you can see all the various values. And you can see that the length is 9. This is not a sparse array, so this is the number of elements contained within the array. Here's the sparse array. So we have an element at 0. So we included an explicit 0 value there. And then we had several undefined elements. Those aren't even listed. So if you have a sparse array, the array doesn't create an index for each intervening value. And then the element at index 5 is 2000, 7 is foo, 8 is 326, and once again, because this is a sparse array, the length value returns a number 1 greater than the highest index value in use. And that, in fact, is always the value of length. Whether it's a sparse array or what's called a dense array, then this number is always going to be 1 greater than the highest index number, even if there aren't actually that many elements within the array. So sometimes that makes a difference within your code. All right, then weird array. This is kind of weird because we have a length of 5. But it's kind of strange, as the name of the array probably suggests. If you count the number of commas here, there's 1, 2, 3, 4, 5 commas separating what should be 6 values. And yet if I go back over here, it has a length of 5. They're all undefined, so there aren't actually any array indexes at any of those positions. But why the discrepancy between 5 and 6? Well, what you have to understand is that in JavaScript, a trailing comma with no value after it, like this situation right here, is ignored. So even though it looks like you should get 6 values, an array of length 6, you actually only get an array that has a length of 5. All right, you can also create an array with the array constructor. And that's what this code here does. Remember that an object constructor is a method that may take arguments and returns a new instance of an object of the specified type. So there's 3 ways to use the array constructor. You can call the constructor with no arguments. And this will create an empty array of length 0. So I can hover over that and see that it has no elements and the length is 0. You can also call the constructor with a single integer argument. This creates an array with a specified length, here 5, and this is useful when you know in advance the size of the array you need. The resulting array contains no values, but it's of the specified length. One thing to understand about this form of using the array constructor is that if you pass anything but a non-negative integer numeric value, you'll get an invalid array length error in most JavaScript implementations. And then the final way of creating the array is to call the constructor with either a single non-numeric argument or multiple arguments of whatever data types you want. The result of this use of the array constructor is an array with the argument values as the initial values in the array. Now, one limitation of this is that you can't use this method to create a sparse array. If you try to do that, you'll cause an unexpected token error in most JavaScript implementations. So this code here is going to result in the same kind of array with mixed data that you saw earlier for this mixed array. And so you can hover over that and see the various values there. The array literal and the array constructor techniques have the same end result, even though each gets there a little bit differently. Usually, array literals are a little easier to use and generally require less typing. But the constructor can be easier in some situations, such as if you want to pre-allocate a fixed array size, and that was that example right here. But use whatever technique makes you happiest. Accessing an array element to read the value or change it, it's pretty simple and straightforward. Just use the square bracket operator with an expression that evaluates to a non-negative integer or literal. If it's evaluated as part of an expression, the expression evaluates to the value of the element for that index. If you use the expression on the left side of an assignment operator, JavaScript updates the value of the element. Here's some code that shows some examples of reading and changing the element at index 3 of this mixed array. Keep in mind that this is the fourth element in the array, because array indexes are zero-based. And then it displays the result. So we can look at the results here. And so the result of this console.log statement is that mixed array 3 is going to return a value of 2. If we go back up to the definition of mixed array, you can see that 0, 1, 2, 3 is in fact a value of 2. And then the next line of code updates the value of that array element with a string. Just because I originally created the array with a value, an integer value at that location, doesn't mean that it needs to stay that same data type. And so mixed array element at index 3 now is a string, and you can see that right there. Where things get interesting is how JavaScript treats and uses the index values. At their core, arrays are just a particular kind of object, using the same property access syntax that you learned about a little bit earlier in the course. The square bracket operator works exactly the same for objects as it does for arrays. You use them as a way to access the properties of an object. When you use a numeric value as the index of an array, JavaScript converts the index to a string to access the property with that name. So in these two statements right here, where I'm reading the value and writing to the value, JavaScript is actually executing a statement like this right there. In this case, it's using a literal string literal, as the index into the array. And as you can see, when you use that notation, it returns the same value, because this, strictly speaking, is what JavaScript is doing behind the scenes. This works because, in essence, the indexes of an array are property names. And that means that you can do the same sorts of things with objects. So here I create an empty object, and then I want to assign weird, the literal string weird, to a property called 3. And that works just fine. The main thing that's different between objects and arrays is that when you use an index that is a non-negative 32-bit integer, the array will maintain the value of the length property for you automatically. It'll always be 1 greater than the highest index value in use, and you saw several examples of that. Where it really gets interesting is that because an array is an object, you can dynamically create new properties on it. If the property name is such, is a non-negative 32-bit integer, then the array is going to treat it as an index value. If it's anything else, the array treats it as a property name, assuming that the value is convertible to a string. That's a valid JavaScript identifier. So here's some code that shows that. So this line of code adds another array element index 5 and sets its value to true. And then it adds 3 properties to that object. First property has the name of name and assign the string JavaScript. And the second uses the value at mixed array, the index 6, so whatever that value is, and sets that property value to my home state. This value happens to be Alaska, as you can see if I hover over there. So the value of the 6th element is Alaska. So this is going to create a property of that object called Alaska. And then the third property added here has the name -472.4, which is a very strange but valid property name. And so the end result, you can see, is that you have a property name called -472.4, which is assigned a property. So you can see that you can get into some very weird behaviors and properties of both objects and arrays. There are 2 ways to add elements to an existing array. The first way you've already seen in action a number of times. Simply assign values to indexes that don't already exist in the array. And then the second way is to use the push method of the array object. Here's a bit of a contrived example. It starts with the int array that was created earlier in the page. This starts life with 7 array elements with a maximum index value of 6. And this displays the number of elements that it currently has. As you can see, it starts out life with 7 elements. The code then uses this loop in order to add elements, starting with the next available index number, which is 7, which is contained within this count variable. So it reads the length from the array. And what it does is it doubles the index number each time through the loop. And then it creates an array element with that new index number, and then sets the value to element dash and that number. So here's the end result. So these are the original values, those 7 original values, and then here are the new values. And I'll talk about these additional elements, 57 through 59, in just a moment. Okay, so that shows how easy it is to add array elements. In this case, it created array elements at specific locations, creating a sparse array. But if you want to add elements to the end of the array rather than at a specific index location, then you can use the array object's push method. And that's what this code does right here. The method takes a variable number of arguments, 1 for each value you want to add to the array. And so this line of code adds 3 of our dogs' names to that array after the last existing index. So if I once again look at that, you can now see and understand all of the elements that were generated. These are the original 7 elements. These were added dynamically as sparse elements, and then use the push method to add consecutive array indexes after the highest existing number automatically as part of the arguments to that push method. You can also delete array elements, and there are 3 ways to do that. The delete operator works with array elements pretty much as it works with objects. And then you can write to the length property. Somewhat surprisingly, the length property is writable. And then the third way is using the pop method. Here's some code that shows how you can delete some array indexes. It starts out by creating an empty numbers array, and then using the push method and adding array elements from 1 to 15. So it starts out life with 15 elements. Then it uses this code, the delete operator, in order to delete array indexes at 2, 3, and 4. So the overall result of this is it changes a dense array with numbers at every index into a sparse array. And then after it does that, it once again displays the length. So there you can see the numbers.length is 15. The numbers.length after you delete the array elements is still 15. Nothing here has compressed the size of the array. And so if I look at the current structure of the array, you can see that we have indexes at 0, 1, skip 2, 3, and 4 that were deleted, and then continue on with 5, 6, 7, 8, and 9, and so forth. So deleting the array indexes didn't shift anything forward. And so the end result is that the length is still 1 greater than the highest index currently in use. The other 2 ways to delete array elements remove elements from the end of the array. And the first one is using the read-write length property. When you change its value to anything less than its current value, it removes elements with indexes greater than the new value. So here's some code that creates a new numbers len array, pushes all of those values onto it again, so we have an identical kind of an array, a dense array, displays the length, and then sets the length to 5, and once again displays the length. I'll put a breakpoint there and continue executing. And you can see that it started out with a length of 15, and now the length property is actually changed and it only has 5 elements. If we look at the contents, you can see in fact there are only 5 elements of the array. So by writing to the length property, it threw away the additional array elements that were greater than the length specified. You can also set the length property of an array to a value greater than its current length. And in that case, it doesn't create any new elements. It just adds a sparse area to the end of the array to create the length that you specify. Okay, the third way to delete array elements is with the pop method of the array object. This method removes the last element from the array and returns it and shortens the length of the array by 1. So this code creates yet another dense array called numbers pop, numbers from 1 to 15, displays the length of it, and then pops off different values and along the way displays what those values were. So I have a breakpoint set at the end of the script so I can continue executing. And so you can see that the starting length was 15 and then popped the value of 15, so it pops off the last element first, and then it pops off the next one, which is the current last element, and then continues on down. And then as you can see, after you pop off those 6 values, the array length has decreased by 6. And you can use the developer tools in the console window to see the resulting array. Notice that you still have 0, 1, 2, 3, 4, 5, 6, 7, 8, and we have 9 elements, and the length of the array is now shortened. The array object is rich with functionality. It implements a number of methods that make working with arrays in code very easy. And here are a few of the more useful methods that you can make use of. You can use concat to create and return a new array with the contents of the original array with additional elements passed as arguments to the methods, and they're added to the end of the array. The join method converts all of the element values to strings and concatenates them together, delimited by a default with a comma, or you can specify any other character. Reverse reverses the order of the elements. Shift is interesting because it behaves like pop, but removes an element from the start of the array instead of from the end. Slice lets you slice out a subarray. Sort lets you sort the array elements, which is by default in alphabetical order. If you want to sort them in any other order, you can pass a comparison function as an argument in order to change the sort order. Splice is a general purpose method for inserting or removing elements to or from an array. And unshift behaves like push, but adds an element to the start of the array instead of the end. And it shifts all the existing array elements up to make room.